Suppose that yes, v1, v2, v3 is a linearly independent set. Okay, is w1, w2, w3, where w1 is defined v1 minus v2, w2 is defined in this way. Is w linearly dependent or linearly independent? Justify your answer. So we need to show if this set where we have w1, w2 and w3 are linearly independent or dependent. So we start writing this set. So consider C1 W1, because we are concerned with this set, plus C2 W2 plus C3 W3, where C1, C2 and C3 are constants, equals 0. So we consider this vector equation, and somehow if we are able to show the only solution of this equation is C1 0, C2 0, C3 0, or the trivial solution, in that case W1, W2 and W3 are linearly independent. But if we are able to show like C1 1, 2 or 3, at least one of these three constants is non-zero, but still this linear combination is 0, then these vectors are linearly dependent. Okay, so we consider this. Now we're going to plug in the values of W1, W2 and W3. They are given here. Okay, so that is C1 W1 is given V1 minus V2 plus C2 W2 is given V1 minus V3 plus C3 W3 is given V2 minus V3, that equals 0. So we need to simplify, just distribute. So it's given that V1, V2 and V3 are linearly independent, so we will use that fact later. So let's distribute. Then you can see C1 V1 here plus C2 V1 there. So from these two, V1 and V1, we can factor V1 out. Then so I'm pretty much combining the like terms in terms of vectors. So C1 V1, C2 V1. So I can factor V1 out. That leaves C1 plus C2. So C1 plus C2 V1. Okay. Then how about V2? So we got C1 V2 and C3 V2. Okay, so from there we get V2 factor out. That means C1 minus 1, that's the negative C1 plus C3, or I want to write C3 first, C3 minus C1 V2. In the same way, I got C2 V3, C3 V3. So C2 V3 is negative, C3 V3 is also negative, but let me write in this way, negative C2 and minus C3 V3, that is equal to 0. Okay, so we arrived in this stage, and it's given that V1, V2 and V3 are linearly independent. That means when we have a linear combination of this going to 0, then the constants should be 0. So we have that situation. Look at here, some constant V1 plus some constant V2 plus some constant V3 equals 0. And since V1, V2, V3 are linearly independent, these coefficients must be 0. Okay, so since V1, V2 and V3 are linearly independent, the only solution to this vector equation is C1 plus C2 0, C3 minus C1 0, minus C2 minus C3 equals 0. Okay, now we solve these three equations by some substitution. From this one we get that, move this over, so C3 is same as C1. Okay, now we can replace C3 by C1, and so C3 by, so then this one is what? So let's write everything in terms of C1 and C2. So I'm just going to leave this C1 plus C2 0. From third, C3 is C1, right? C3 is C1. So that's negative C2 minus C1 equals 0. So this one we can factor negative out. That leaves C2 plus C1 equals 0, negative 0, which is same as C1 plus C2 equals 0. Okay, so we got the same thing here, no information. Okay, and what we know is C1 plus C2 0. We got here C1 plus C2 0, and we have C3 equals C1. Can someone give me the solution here? This one, C3 and C1 equal, C1 plus C2 is 0, nothing new, this is same as this. So from these two we know that C1 0, C2 0, C3 0 is a solution, but we want to see if there are other solutions. Okay, because whenever we write this linear combination going to 0, this homogeneous equation, C1 0, C2 0, C3 equals 0 is always a solution, but we are trying to see if that's the only solution. Okay, so from these two now, if we solve, what we're gonna get? Okay, C1 and C3 are equal, so from here C1 is negative C2. Okay, so if I take, I mean, looks like there are infinitely many solutions. How about taking this? C1 is 1. If I take C1 1, then C2 will be what? C2, subtract C1 from both sides, negative 1. Okay, and here C1 is 1, so C3 is also 1. So I could have taken 2 as well. Okay, so I have one solution which is not 0 0 0, and still this linear combination is 0. What is happening here is, in fact, we got three unknowns, C1, C2 and C3, but somehow these two equations are identical. That means I am left with two equations, only two restrictions, but there are three variables. That means one of the variables is free, and since we have a solution and one variable is free, that means we have infinitely many solutions. So one of them is 1, negative 1 and 1. That means this linear combination is 0 without being C1, C2 and C3 all 0. So we have non-trivial solution. So this implies the vector W1, W2 and W3 are linearly dependent. Final.